morning, everyone. I think we have the distinction of having the only tech policy event this week in Washington. So I'm really pleased to be able to host Professor Douglas Fuller today to talk about semiconductor policy in China and India. Doug's in the U.S. this week. He's stationed in China. Anyway, I'm Rob Atkinson, head of ITIF. I want to welcome you to David Hart, who's a professor, actually dean now.
Senior associate.
Sorry, some academic title. George Mason, but is on our board and is a scholar of tech policy. David's going to moderate the event, and we'll go from there.
Thanks, Rob. Yeah, as Rob mentioned, I've been on the board of ITF for a long time. And for those of you here in the room, you know that ITIF is the premier think tank for tech policy issues, but those of you who are watching over the internet or who may watch at some time in the future may not know that, and it's a real privilege to be associated with it. I am with the School of Policy, Government, and International Affairs at George Mason, which was formed over the summer as a merger between the former Public Policy School and the Department of Public and International Affairs. And we're very excited to get this new organization off the ground. It is going to be one of the biggest and broadest public policy schools in the country. And we just welcomed our first group of incoming students this week, so we're real excited about that. Also very happy to be able to moderate this panel with Doug Fuller and colleagues. I met Doug on a project in Hong Kong that he recruited me to a few years ago. And he's currently with the Department of Business Administration in Zhejiang University in Hangzhou, and can give us obviously a close-up view of China's chip industry, but also has been working on comparative industrial policy for many years, and knows a great deal about a wide range of countries. So today's talk on China and India will give you some flavor of the global situation in that sector. And Doug will speak for about 15 or 20 minutes, and then we have three terrific respondents. Well, two terrific ones plus Rob. The first respondent will be David Isaac, who is the Vice President of Government Affairs at the SIA, Semiconductor Industry Association, and he leads the association's work in policy and advocacy here in Washington related to all branches of the U.S. government. Jimmy Goodrich, our second respondent, is the Director of Global Policy here at ITI. Are there partners? There are sibling organizations, something like that, here in the building. ITI is the Information Technology Industry Council, which is a leading trade association in the IT sector. And finally, Rob Atkinson, whom we all know and love. Please come on in, have a seat up front. There's plenty of seats. And with that, I will turn it over to Doug. Thanks.
Thank you. I'm very happy to be here today. I should have known, since it's Washington, and that I should have put the emphasis on policy. I teach at a business school, so I focused a bit more on the firm level and sort of the firm dynamics. But I'll try to switch the emphasis here for this talk. So. Next slide, I guess. Basically, I've been following the Chinese industry for 12, 13 years now. But for the Indian industry, I just started to do research there in 2007. But what struck me when looking at the two industries is sort of the narrative you hear from multinationals when they face them. If you look at World Bank metrics or those by Gwartney, there's different ways that they measure IPR protection. And frankly, in some measures, China looks better than India, and other measures, India looks better than China. But when you talk to multinational firms on the ground in both countries, there was a pretty consistent narrative in this industry that IPR protection was very bad in China, and actually, whether or not the protection was good in India, there just wasn't very much theft. And so multinationals were much more relaxed about having sophisticated operations there. Having said that, the IP concerns in China have diminished over time, but there's still much more an emphasis on informal mechanisms within the firms to protect their IP. The other main difference is obviously was in China you have this huge electronics assembly industry, and in India not very much of one. And furthermore, in India you already had this template, this model of very successful IT services, and they were already extending that model into integrated circuit design services. Next slide. So you saw two really divergent models emerging. Both countries have large engineering workforces, just in absolute terms. Both have, in this industry, engaged with the international economy, but they actually look quite different. So the multinationals came much more heavily and much earlier to India to do serious IC design work. And furthermore, they were sort of helped along this path by these IT service firms, some of whom committed to creating very large integrated circuit design workforces in the thousands. Which here, when I'm talking about IC design, I'm just talking about VLSI design narrowly defined, not the software around it. So several thousand engineers in this area is quite a large workforce. And so if you look at India, by 2008, you had basically all of the top 20 of the firms, except some of the Japanese ones, doing VLSI design in India, and many of them had been there for a long time. So eight of those.
Doug, do you want to explain to everybody what VSLI means?
Well, the acronym stands for Very Large Scale Integration, but here I'm talking about the actual circuitry design rather than the peripheral software design that's associated also with integrated circuits, if that, the actual things that are etched into wafers, if that's a helpful way to put it. And for these design service firms that not only helped ease the multinationals into coming to India, but actually grew alongside of them, they served as a template for what a successful startup in India would be like in this industry. So when an entrepreneur wanted to start up an IC design firm in India, they said, oh, well, design service, that's obviously the way to go. And one of the advantages of this is this method was it was actually also very low cost. They generally did not need to seek outside venture investment. They typically looked to the multinational partners to give them the EDA tools. So the investment was also very low. So they created this very MNC-centric design service model. The MNCs had their own large design centers and also made use of these design service firms that grew up alongside them. In China, it was a very different, next slide please, different case. Prior to 2000, you saw very few of the largest multinational firms having active design operations there, and when they did, they often were quite small. The local firms, however, unlike in India, they had a very large manufacturing base to sell into. Furthermore, at least from about 2000 onwards, there was sort of a boom in venture investment in this area. Maybe too much of a boom, maybe there was overinvestment in this sector, particularly by Taiwanese venture capital, but money was readily available. And so here, when it was local firms, they basically focused on being product firms. They wanted to design their own IC product that then they sold into the marketplace, rather than being design service firms. There were a few design service firms in China, but that was not the primary model. Of course, this product focus also just heightened sort of the fears of the multinationals, right? In India, you didn't see many of these product firms. So they weren't as concerned about having their IP stolen. However, what you really see is the large commitment of multinationals to India vis-a-vis China led to much more sophisticated activities happening. However, because of that design service model, you did not really see much value capture. Especially initially, the Indian design service industry was really sort of body shopping. Now, I'm sorry, next slide, please. The Indian design service firms, when I first went and talked in 2007, 2008, they had all these plans to capture more value, to sort of get out of this low value capture mode of just shopping engineers to multinational firms. They wanted to have much more turnkey solutions that they would sell to the multinationals, and some of them even talked about sort of aggressive patenting of some of the IP they created themselves. But when I went back this year twice to see what the IC design service firms were doing, they're still quite constrained. They're still basically doing these models that aren't capturing a lot of value, such as the time and materials body shopping model, and revenue sharing royalty models, even for the more successful firms, are not the majority of, or even close to the majority of their revenue. And the design service firms themselves admit that there's a basic reason why this hasn't gone very far. There's a conflict of interest. The multinationals want to keep the value and use them for the body shopping, and so they're not really that excited about encouraging this move for more value capture on the part of these design service firms. And next slide, please. In China, which I've been following for a longer period of time, but just to give a same sort of era snapshot, more and more multinationals started to set up significant design operations from about 2005. And at the same time, venture capital, particularly foreign or overseas Chinese venture capital, was starting to lose interest in investing in this sector. So it looked as if China was actually going to have a much more substantial multinational presence. What I find interesting, and it has, if you look over since 2005 or longer, it has substantially increased. But what's interesting is that they don't really have the depth of commitment or the scale of operations that you see in India. And in fact, many of the MNCs who made a big splash by hiring a lot of engineers, particularly in Shanghai, have since their initial foray sort of cut back on their operations in China, particularly when you compare the same firms and their operations in India. However, the Chinese government, and I'll talk about this in more detail later on, has had a very significant renewed push in this sector to try to promote the industry in general. Next slide. So in 2008, you would see much more sophisticated activities in India than China. Here I talk about design leads, essentially people who are in charge of a whole design project, whether or not that project takes place entirely in the subsidiary location in China and India, or is sort of a cross-border project. 14 of the 19 multinationals had design leads in their Indian operation, and 12 of the firms had pretty substantial groups of designers, over 100 designers. And a number of those firms had large analog mixed signal teams. If you look at China, fewer MNCs were active. They had fewer design leads, smaller teams, and much less of an emphasis on analog and mixed signal teams. Looking at 2014, next slide, please. Basically, you still see a fair amount of growth in the teams in India, both in terms of their sheer size. A few of them, because the overall global firms have cut back or given up certain business units, and those business units obviously also closed in India. But most of them have grown, and most of them have added more design leads and more analog mixed signal teams. In contrast, in China, a lot of the multinationals, 7 out of 10, cut back or completely closed their design operations. And keep in mind, a lot of these teams still have a large software presence in China. But I'm looking at it much more narrowly at the VLSI aspect of it. And there were only 2 multinationals with design ops in China that were comparable to those in India. If we look at, next slide, the value capture and technology creation, in the early days, 2003 to 2007, India had many more patents, lead inventor patents, than China. But they were all owned by multinational firms, whereas in China, half of them were owned by local or hybrid firms that were theoretically that were foreign invested, but were basically based in China. And if you look in terms of just sheer revenue created, China was much further ahead. If you look at 2007 to 2011, next slide, China has caught up to, or is closing the gap with India in terms of overall patent generation. And more to the point that the multinationals in India are still quite dominant, where in China there has been much more of an equitable distribution between the local and hybrid firms vis-a-vis the multinationals.
Are these SIPO patents for Chinese patents, or are they?
No, these are U.S. utility patents. I don't Chinese patents.
No, exactly. That's my
worthless.
They're worthless. It's like, why not?
I use patents where it costs a lot of money to actually get the patent, so that they might be worth obtaining. So, next slide, please. What's also interesting that's been happening and not surprising is the narrowing of the cost differentials, particularly in China. When you think of the IC design industry in China, it's very heavily, if you're talking about actual design, Shanghai-based, and Shanghai's become quite expensive now. In 2002, engineers there, design engineers, probably their total cost about half of what they were in Taiwan. Now, firm after firm said the costs are equivalent or maybe even a little higher in Shanghai, and this included firms that had operations in both sites. And even vis-a-vis the US, they've caught up a bit. In India, in local terms, salaries have skyrocketed, but obviously the rupee's been relatively weak, so that's kept the US comparison somewhat more in check. But what's been interesting is there's this very clearly now the very deep market, given all of the multinational presence and the large local design teams. There's a very deep market in this area that's encouraged more people to enter this workforce. And there's been a proliferation of mechanisms to get into this workforce. So there's more and more of these private training institutes, sometimes affiliated with colleges in places like Bangalore. Now, the multinationals themselves aren't necessarily hiring those graduates, but a lot of the design service firms are, and then they work there for a few years, and then sometimes they are then hired on by the multinationals. Whereas in China, not that there hasn't been an increase, because there's been this tremendous increase in tertiary education and S&T education, and also just specifically microelectronics education. But at least anecdotally, there seems to be something of a backlash in this area. Because there's been layoffs at these multinationals, and there's not as many of them there in the largest market for this industry in Shanghai, it sort of sent out signals that, well, maybe as an engineer you should focus on some other area, maybe go into software and not go into integrated circuit design. There are local firms, some of them quite large, like HiSilicon, Huawei's affiliate, but there's definitely a bifurcation in the labor market in terms of, as one person I interviewed put it, that sort of the Korean practices of firms like HiSilicon. They're very rigidly managed organizations. So the people who sort of enjoyed the Silicon Valley type human resource management practices of the multinationals, it was probably hard for them to adjust, or not even appealing to go to those types of organizations. So overall, there's at least the possibility that there's going to be constraints on this labor pool in China, where in India, you know, if you look around at the only places like Facebook and Google are paying better salaries than VLSI design. So it's a very appealing area to go into. And next slide, please. So, sum up these constraints. Basically, in India, multinationals have continued to dominate. The design service promise to try to capture more value has seemed to be hard to realize. And the other route, to start developing actual products, has been handicapped that there's not really much of a manufacturing industry in India. Even a lot of these new Indian sort of smartphone design firms, really a lot of them are labels that are relying on manufacturing and design that takes place in places like China. For China, you see a lot more, at least in sort of top line view of things, a lot more local product firms that seem promising. But if you look at them closely, it's questionable if they're actually making any money, or if there's any sustainability in what they're doing. They tend to be at the low end of whatever market they're in. A lot of them are being very hard pressed by multinationals, or quasi-multinational. NTK, a Taiwanese firm, not really a Chinese firm. The one standout success story is probably HiSilicon, but it's basically a Huawei branch, and that's both good for it, but also limiting. Other firms are not necessarily wanting to use them because of that connection. So given these constraints, then next slide. What has each country thought about doing about this? And one of the interesting rhetorical similarities is both countries like to point out that they either are or about to be spending more money on semiconductor imports than oil imports. Of course, in the China's case, since it's this huge electronics platform, they're also exporting a lot of that ICs they import. But in both cases, they come up with sort of this trade deficit argument. But for India, it's really a question of well, we have to develop a manufacturing base more broadly to make the electronics boxes, so we can, create an industry and create a market to sell integrated circuits into. So they've come up with a variety of proposals to do this. This national electronics policy from 2012, and then follow on from that, these electronics manufacturing clusters, of which 8 at least have in principle been approved, to try to foster a much more dynamic electronics manufacturing base. However, these, if you want to use China as a comparator, the scale of these is quite small. So this greenfield site, this EMC site in Odisha, that was just approved in June of this year. It's only going to employ 10 to 12,000 workers maximum. And if you go to any of these large development zones in China, there are many factory sites owned by just one firm that employ that number of workers or more. So it's still a long way away from having this large scale that you see in China. And there are these talks about having fabs, these 2 plans for fabs, and subsidies for them of 20% if they're in the special economic zones and 25% if they're not. And also venture capital funding geared more towards the box manufacturers than the IC design. But thus far, I mean, there was expectation that with the new Modi government, there'd be a lot more policy activity coming out, but it's thus far it seems to have come out in drips and drabs. On the Chinese side, in the past, they already threw lots of money at the problem. At least one well-informed interview subject I talked to argued somewhat convincingly that from about 2011 to 2015, through 3 5-year plans, not including the new sum of money that's been put on the table, probably 300 billion renminbi was spent on this industry. The problem that he argued and other officials and industry insiders argue in China is that the spending was quite diffuse. A lot of it was local government spending. It was scattered all over the country. Maybe some of the vehicles through which it was spent, research institutes or certain state-owned firms, were not actually quality targets for this money to be spent. So, with the recognition that they haven't really gotten a lot out of their investment thus far, and all the heightened security concerns, but especially after Snowden, there's been this renewed push, and this really goes back to the 2009 SEI, but it continues now, to spend a lot more money on this area and much more concentrated funds. Now, there was this June announcement, but it was suitably vague in terms of the monetary amounts that were going to be spent. I think the most significant thing as a signal to prioritization was this IC leading small group that they announced as part of this. So there's going to be, this group at the top of the party-state structure who's going to be responsible for coordinating and carrying out policy in this one industry area. Having said all that, some of the headline figures that have been thrown out are enormous, some of them crazily large. I've seen even 3 to 5 trillion renminbi over the next 5 to 10 years. I don't believe that. I think that's sort of conflating ICs with some of the other areas that they're going to spend in these mega projects. But even if it's somewhat smaller sums, like 120 renminbi investment fund, these are quite large sums of money, even when you put them in US dollar terms. And even if you consider that a fair amount of this may be capital expenditure on the fab side rather than on the IC side. However, I mean, Jimmy probably disagrees, but I am a bit skeptical. I'm a big believer in their past trajectory still saying a lot about their future policy direction. I think that they'll end up targeting perhaps the wrong firms overall to spend this money, or they'll undermine some good firms by throwing money at them. So in the last 6 months, you've seen all these firms delisting from foreign stock exchanges. These were all sort of these classic hybrid type firms, so Spreadtrum, RDA, Montage. Now even Omnivision is talked about as a takeover target. And basically what happens is they're being privatized. They're privatized in the sense that state organs or state-linked firms in China are taking over these firms. And I'm skeptical that will prove an effective mechanism for developing this industry. Thank you.
Thank you, Deb. So let me just invite those of you in the back. There are some seats in the crowd, and now's a good time if you'd like to take one. So we have 3 respondents, as I mentioned, and the first is David Isaacs from the SIA.
Great, thank you, and thanks to ITIF for convening this session, and thank you, Professor Fuller, for your insights. I'm here pinch hitting for the SIA president, Brian Toohey, who sends his regrets that he couldn't make it. So we've been following this area very closely and appreciate the professor's insights on the developments in these 2 countries, which are so important to the global technology market. And I think the one common theme that's apparent is that both countries are focused on building their domestic semiconductor industry. They identify it as a strategic industry for their economy and future growth and leadership, and so they're very focused on that, and we applaud them for doing that. We think that could help the pace of innovation and growth in the industry. As the professor indicated, India is ramped up their design efforts. They're now turning to manufacturing and trying to build some fabs. I think they're facing some difficulties with financing and with basic infrastructure and reliability issues, and we'll see what happens there. We've been at SIA much more focused on the developments in China. The professor mentioned the announcements in June, and that has certainly caught our attention. China is very, very dependent on foreign sources of semiconductors, and there's different numbers, different methodologies of counting these things, but as was noted, they by some ways of counting, it's their #1 import, more than petroleum, and of course, it's a key part of their exports that is so central to their economy. So these are big issues for them, but they also view it as not only an economic vulnerability, but a national security vulnerability and a cybersecurity vulnerability. So they very much want to build their own industry, and these new efforts, the announcement of new document 4 in June, and the announcement of this leading group, they have very, very high level buy-in by President Xi Jinping himself, Vice Premier Ma Kai, and others are very focused on this effort. And in other industries, we've seen this movie before and know how the story ends. And so this is a very significant effort on the part of the Chinese, and something I think we all need to pay close attention to. And China has been implementing a series of integrated and complementary policies, whether it's on the trade front or IP, the recent anti-monopoly law activity, to grow their domestic industry. But the big game changer perhaps is this IC investment fund, and the details are still emerging. As Professor Fuller pointed out, we really don't know the dollars and how much of it is new money and where it will be focused. But so we're awaiting the rules and to be issued, and we're trying to engage both with the Chinese government and with the local industry to ensure that they don't replicate what they've tried in the past, that they make sure it's market-based, and that it's more an open and transparent approach. And there's some early indications that they're doing so, but the announcements have been somewhat cryptic, and we'll have to await further details. But with regard to both China and India, we strongly believe, and we're in our conversations are encouraging them that the way to succeed in this effort is to integrate into the global semiconductor ecosystem that has emerged over the past several decades. And it's a very vibrant and complex network of pre-competitive research, of collaboration on standards, on the whole supply chain of manufacturing tools and process chemicals, supported by government policies like protection of IP and open trade rules. It's that whole basket of the ecosystem that we think that no single company, no single country even can go it alone and expect to succeed in this industry. It's not like other industries where you just throw a lot of money into it and build up capacity and become a leading edge industry. So we're hopeful that both China and India will take that approach, and we're working closely with them, again, both the industry and the government, to try to guide them in that direction, and we look forward to partnering with them as they proceed. So I'll leave it there and we can move on.
Thank you very much, David. Our next speaker is Jimmy Goodrich from ITI.
Thanks, and also it's great to have the opportunity to comment on Professor Fuller's paper. I think it's actually very timely. Here at ITI, we've done a lot of work working with governments both in India and China, particularly on some of the growing trends regarding forced localization policies, which I think play a unique dynamic here from a policy perspective, looking at the role of multinational companies in investment, not only in the IC industries, but also ICT in general, in economies where governments are pursuing sometimes aggressive industrial policies to promote their own industries. And it's interesting that, in your paper and your research, you saw sort of natural flows towards both market where it made sense based on market decisions to make those investments in the country. So China, obviously, one area where there's a lot of investment by multinational companies is in testing, assembly, verification, particularly in the semiconductor industry, and that's because the supply chains are there. The electronics base is based out of southern China, eastern China, and so you have a natural, and that's been a natural pull for multinational companies for quite some time. And that has grown organically in China over the last 2 decades, not because the government required those firms to be there, but because of cost advantages, shipping, transportation, infrastructure, tax incentives. These policies have been in place for quite some time. India, on the other hand, quite interesting that you have design locating there early on in before potentially 2000 and after, because of access to talent, intellectual property, and so the industry streams that moved there, as you highlighted, were towards the higher end of the intellectual property cycle and of more value, but and a lot of that contributed by multinational companies. Now, interesting that what we've seen is 2 sort of dynamics in India and in China. One, China in 2007 came out with its indigenous innovation plan and had a number of policy tools, from government procurement to the implementation of their anti-monopoly law, potential selective protection of intellectual property rights, aimed at upgrading China's own indigenous innovation capabilities. And it was actually right at that time in 2007 that your paper highlights that interest by the global IT community in China around strategic R&D investments, particularly also in the semiconductor industry, were curtailed a bit. And I think some of the messaging from the government at the time about the need to have Chinese intellectual property in order to qualify for procurements, in order to qualify for tax breaks, the government started shifting a lot of those incentives towards domestic firms that were owned and operated by Chinese enterprises. So interest amongst the global industry was curtailed a bit when China started experimenting with some of their more aggressive industrial policies in the name of forced localization, where local content was being required by the government from a policy perspective in order to do business there. And we saw that in the government procurement regulations. Then also India, which wants to grow its manufacturing base, as you noted in their electronics plan. A couple years ago, part of their electronics plan came out with their PMA, or their preferential market access policy. India also has ambitions, as you've noted. They want to grow out their electronics supply chain base, but they started doing it on a forced implementation basis, where multinationals, be they Japanese, Chinese, US, if they wanted to sell into the Indian market, into the not only government procurement but also private sector market, would have to start manufacturing locally, and this would be a requirement. Now they've since walked back from that quite extensively to limit that only to implementation within the government procurement sector, which still is obviously a concern for the global industry, but that's also spooked some of the investors within India. So you've seen China on the one hand struggling to increase its design capabilities, and then India on the other hand struggling to grow its manufacturing base around electronics. And both governments of the last 5 years have tried the aggressive approach is to, well, if the multinationals aren't coming here, let's mandate them to come here because our market's big enough. We think they'll come anyways. And we've advocated that those policies at the end of the day do not work. The multinationals and clusters around investments in the ITT sector in various regions have grown organically because of market conditions. And firms, and then in your paper, whether it be in India, are investing in design services because the right conditions are there. And the government indirectly helped in creating them by supporting education, intellectual property protection, China by making infrastructure available to facilitate the electronic space. And so hopefully now what we're going to see, and I think your paper is timely, is China and India is trying to learn that the forced manufacturing or the forced design and intellectual property route is not necessarily the way to move forward. And what's interesting is that both India and China come at it from a perspective that they like to both vertically and horizontally have it all within the sector. I mean, you talk to governments in both countries, and they want to have all sort of pieces of the supply chain or the ecosystem within their country and have a strong national industrial base. But if they were as David mentioned, particularly the semiconductor industry is very global. If they want to compete or grow companies that are going to be able to be leading players in the semiconductor space, they'll have to be like a multinational as well. And the fact that multinationals have testing and assembly in China and they have design in India and huge design centers in their home countries speaks to the fact that this industry cannot be grown out of one country alone. And we're hopefully seeing more realization, particularly in India and other countries, that that's the reality that they have to deal with in order to grow their firms. They need to integrate into the global industry supply chain, as David mentioned. But I'll speak a little bit now about China. I think this is very interesting. As Professor Fuller mentioned, they've gone through various rounds of trying to grow out their domestic IC industry, their domestic electronics industry. It's been more or less a failure since the 1980s. There have been numerous large mega projects, government investments, huge standards initiatives. A lot of the money has gone into state research institutes, hundreds of them to 30 provinces around the country. So there's a lot, but it doesn't scale to the size that China has wanted to. So the new plan, as you've mentioned, is trying to reverse all these trends. They're trying to have large investments in the hands of a few companies, geographically limited to Beijing, Shanghai, Chengdu, and Guangzhou. So it's fewer cities. But the problem is, even though the money, as we know it, is going to be spent through investment arms, it's still government money. And the government, at the end of the day, are going to be making a number of strategic decisions. And as you've mentioned before, a lot of the Chinese design firms or product development firms in the IC sector, they've been more or less subsistent on government subsidies. And the increasing role of the government, particularly around investments, is going to it may be counterproductive. I think you may I think some of your predictions there are helpful and should be useful for actors in China to think about as they want to build out their semiconductor industry and their IC industry and their tech industry in a way that's more globally aligned and embracing global norms. So I'll just stop there and turn over to Bob. Thanks.
Okay, well, thanks, Doug. I thought that was a great presentation. I want to just make 2 quick points, but had 2 questions for you, Doug. Also, maybe one is you mentioned the wage ratio in India for an entry-level person 1 to 7, and I'm just curious if you benchmark that against productivity and quality. Is it obviously lower productivity, lower quality? You assume. And the second question is, which is one I still cannot figure out fundamentally what the Chinese motivation is on all of this, is at the end of the day, I think it's a combination of things, but I'm just curious of your thoughts on how much of this really fundamentally is about building up defense capabilities so that they are on par with us over the next 30 years, and they have to have an IC industry to be on par with us from defense and weapons systems, or how much it is just pure economic policy. So I'd just be curious about that. So the 2 main thoughts I want to argue is, one is I maybe differ a little bit from David. David sort of has to say some of this stuff just because it's politic, and I don't. So I actually don't think this is good for the global IC innovation system, at least the way India and China have structured their programs. I think it's actually, at the end of the day, going to lead to less global IC innovation than more. This is in part based on a report, journal article I published this spring in the thing called the Journal of Global Policy, which was a piece on a framework for maximizing global innovation. So in one way, these policies could be good for global IC innovation in the sense that they're around skill development. So particularly India, that's good. The more IC engineers you have and circuit designers, that's good. We certainly need more in the U.S. To the extent these companies are patenting, that's good. It's adding to the global knowledge pool. And to the extent that they provide lower cost engineers and designers and scientists, that's good as well, because it allows the global economy to employ more people thinking about design and circuit building. All good. But I think outweighing those 3 positives are 3 significant negatives. One is this question of excess capacity. We see this in particular historically with Korea subsidizing their semiconductor firms that really should go bankrupt. They're just adding to global capacity, and they're bringing everybody else's margins down so they can't reinvest in innovation. I think Chinese overcapacity is going to lead to the same exact problem. This is a highly capital intensive and R&D intensive industry that you got to have what are called Schumpeterian profits to make it work. And if you start getting dry cleaner level profits, you just don't get innovation. The second problem is rampant IPR theft. There's a study by my colleague Peter Cowie at UC San Diego. We're both on this U.S.-China Innovation Experts panel, and as part of that effort, Peter conducted a study with some Chinese colleagues looking at the attitudes of Chinese semiconductor, the views of Chinese semiconductor firms, so indigenous Chinese firms, on IPR policies in China. And the Chinese semiconductor firms said that the weak IPR is holding back China. So I think essentially, and it's not just sort of weak by happenstance, it's weak by design. And we saw that with the Chengdu court case recently, basically saying that they should force foreign companies to turn over IP with low licensing fees. That fundamentally is going to, I think, hurt global innovation. And the last component is really this notion of a smaller market, which is related to the first point. But some of the Chinese policies, particularly this new Chinese semiconductor policy, Circular 4, is that what it's called? Document 4. Involve Chinese-only domestic standards, and that's fundamentally bifurcating and segmenting the global market again. And what you want in these markets, these innovation markets, is you want scale. That drives innovation. And so I think particularly the Chinese policies are going to end up hurting us. But let me just close by saying I think also these policies fundamentally are not the right economic policies for either country. India in particular, there's been a lot of work. There's a great report that my colleague Stephen Ezell did on India, which is back there if you haven't seen it. But there's a nice study by these Indian economists, and they looked at the last time India tried to build a domestic IT industry through tariffs. This time they're doing it through forced procurement. But the last time they did it through tariffs. It was utter failure. But what these two Indian economists found was that for every dollar of tariffs that the Indians put on IT imports, which included ICs, they were losing $1.37 in economic activity. As they said, they make it on volume. But why did they lose money? Because they ended up raising the cost of this core general purpose technology input. So all the firms in India that were using computers and IT and servers and all that, the banks and the retail firm, everybody, they were all paying higher prices, using less IT, lowering overall Indian productivity. And the PMA policy that Jimmy alluded to, the preferential market access program, going to do exactly the same thing, which is really sort of, in one way, sort of troubling for India, because India's advantage really has been on, as Doug said, design and IT services. And so all they're going to do is they're just going to raise prices for that, the industry they're really good at, plus all the others. So I think for India, it's just a bad policy. India's could do a lot better if they just sort of build up their core manufacturing overall, things like plastic parts and autos, and that's their competitive advantage. They're trying to leap way, way too far to something they just can't do. They're going to lose a lot of money, and they're going to end up with these secondary negative impacts. For China, I go both to Doug and Jimmy's point about it. It's not even clear that the Chinese policies are going to work. I remember about a couple of years ago, I was over in Beijing, and I was talking to an NDRC official, and he used the word, it was a funny word, he used the word that in Chinese industrial policy there have been a series of tragedies. So that was an interesting word. I thought he meant like, factories collapsing and killing workers, but no. He talked about one tragedy where the Chinese government had put an enormous amount of money into this incredibly cutting-edge technology to build all these factories called VCRs. And this was like a year before before discs, before DVDs came out. So they built all these VCR factory and all this, and then nobody buys VCRs anymore. And they just completely missed the whole sort of evolution up to this new technology. And he used the word tragedy for that. And it's not clear that they're going to be any better. I mean, the Chinese are really, really good at learning. I give them a lot of credit for that. They try to learn from their mistakes, but it's not clear they can do it. The second, I think, big problem for China is, this whole move to indigenous innovation. I think you can make a really good argument that it's 10 years too soon. That they still had a lot of runway left on taking advantage of MNC talent and capabilities and tech transfer that was going on naturally. And I think what we're seeing now, both from Doug's point and Jimmy's point, MNCs are pulling back. They're only going there if the gun is to their head. They have to for market reasons or government reasons. So I think they've really made a strategic mistake at alienating MNCs, and they're not ready, I don't think, to fully go with a domestic indigenous innovation, particularly in semiconductors. And I think that's going to hurt them in the long run. And the last point is, quickly, we did a little back of the envelope calculation of their SEI program, Strategic and Emerging Industries program, which includes semiconductors. And our calculation was, if this program were to succeed, which is billions and hundreds of billions of dollars that the government's going to be spending, if the program were to succeed in all of their aspirations by 2020, it would succeed in basically equaling 14 months of Chinese productivity growth. So not that big a deal. So, all of the wealth that would be created is equal to 14 months of Chinese productivity growth. And so China would be much better off with just across the board, raising productivity in all of their industries, using all of this money for kinds of investments to help all of the firms grow, rather than, I think, end up putting a lot of money into a few industries that fundamentally won't do them that well. Now, again, if this is all a defense policy, then you spend all the money you want. It doesn't really matter. But if it's an economic policy, I think it's a flawed policy. So I'll stop there.
Thank you very much. So we'll open up for questions, but let me just ask Doug to respond to Rob's two questions at the beginning, and then please join the conversation.
Right, the first one was about the wage differential.
1 to 7, yeah.
Yeah, I mean, I don't think anyone in India claims when they first enter the workforce that the skills are evenly matched. but the skills and the salaries both ramp up relatively quickly. So you see at the more senior levels, it narrows quite substantially. And also they've been helped recently, just that the rupee has been very, very weak. So if that hadn't happened, then you would see even narrow differentials. I mean, one thing that initially motivated some of the research, and I think is a concern. The reason we focused on IC design and not sort of assembly and testing, which you alluded to, is because those are jobs that Americans still want to do, assembling and testing. Fine, Malaysia and Philippines and Costa Rica no longer do that, and it goes to China. But there's at least some anecdotal evidence that maybe the training ladder to be a very experienced IC designer in the U.S. is sort of atrophying, because where are they hiring new young people to enter this industry? Well, basically in places like India, probably mainly in India. And you wonder, 20, 30 years down the line, what's going to be left in the U.S. I mean, some of the people working for multinationals, managers and multinationals in India, were sort of almost even crowing about that prospect. Like, well, eventually the weight of it will have to move here because they're just not training people anymore in the States. So I do think there would be a role in the U.S. maybe for some sort of, subsidization of labor force training in this very specific sector to counteract that. On the other issue of how much of it is just a purely defense policy, I mean, that's obviously an element. Techno-nationalism runs strong, and not only in China, but in many places, in India as well. There's an element of that. But I think it's also a very good excuse, if you're a bureaucratic empire builder, that that's a very handy tool in your toolkit to persuade others that we need these very large policies. I'm sure the people in the MIIT are very excited about all of this. So it's not, there's the cynical aspect. I mean, I've even heard people within MIIT sort of bemoan local policy efforts in this area, because they're also I mean, why did all these local governments want to build IC fabs? Well, it boosted the short-term investment inputs that they're sort of graded on in terms of cadre promotion. So it was a very handy way to do that, even if it was poor industrial policy. So there's mixed motives there, and I think on the defense side, there's been, there's all these research institutes in Nanjing that have always been quite, they're also sort of the mixed use places, but if it was purely defense, then we'd just go through, probably through that group.
I think just to add on the China component, I think we've seen some interesting dynamics at play. Obviously, this is a big government industrial policy coming out of Beijing, and any big government industrial policy is going to have a politics are involved. So, it's interesting to note that, why now? Why is China coming out with this renewed strategic focus? If you look at the top 7, officials that run the country from the party, the standing committee, one of them actually comes from the semiconductor industry. So the former party secretary of Shanghai used to be the director general of electronics back in the 80s. And so he himself comes from the industry. He's closely connected to the industry, and when he was, this is Yu Zhengsheng, he's on the standing committee, and so he's one of the top 7 people in the country. And so with him now sitting on the top of the standing, within the standing committee, the top of the party, obviously the industry has a lot more pull politically within the system, access to banks and capital and regulators than they did before. So there has been some, Chinese analysts and insiders who stated, well, this is also, a story of Chinese politics at play, where you have people up top who can favor industries more heavily than they had before, because the semiconductor industry for the last decade really hasn't had in China sort of that high-level support from, the top elite of the party. They did in the late 90s, backed by President Jiang Zemin. His son was involved in the semiconductor industry. He ran the Shanghai Microelectronics Institute. But at the time, maybe because his son was involved in a lot of the state-owned institutes, a lot of the funding went through these government research institutes. So now you have a much higher backing from the Chinese political structure of the industry, and also comes at a time when President Xi Jinping is also much more techno-nationalist than his predecessors. When he travels abroad, he's trying to drive in a Chinese-branded car. His wife uses a ZTE phone, and he's trying really to sort of carry that flag of Chinese-branded industrial strength, and that's kind of influenced a lot of the industrial planners in Beijing. And sort of the focus, I think, Rob, to a little bit on your question, I think we've seen a couple areas. I think it's split. There's a large focus on market-oriented technology, so consumer growth. There's a lot of talk about capturing next generation in their strategic plan growth in the mobile semiconductor space, in things like the Internet of Things. But it's interesting. The plan itself says the government needs to step back. They cannot decide who's going to win in these spaces because it might not be so important at the end of the day for national strategic reasons. Which Chinese company is successful, but they do note that in their plan specifically that for semiconductor applications in spaces such as critical infrastructure, so high-end semiconductor solutions for banking, finance, insurance, telecoms, very sophisticated networking and telecommunications equipment, the government's going to have a very strong hand at subsidizing R&D, coming through, and they even say promoting the application of trusted and secure Chinese semiconductors, and that probably means Chinese-branded semiconductors as well. So you do see sort of a split. Let's grow the industry, but it's also at the same time increase the adoption of Chinese-developed and locally manufactured semiconductors within their critical infrastructure to increase cybersecurity. Whether that's going to be successful, we're not. It's too soon to tell, but time in practice has proven that building very unique solutions, sort of by yourself, ends up with less security. So.
Thanks. So let's take some questions. If you could just identify yourself and keep it tight. Thing over here.
Thanks. Yeah, just two quick questions.
Just identify yourself.
Oh, sorry. Cynthia Johnson with Phillips Instruments. Two quick questions. Some people, and this is, I guess, it's Professor Fuller, is there's some analysis that said that all that past investment that Chinese have made has led to some success in some areas. The design firms you mentioned, there's some evidence that they've made some progress in assembly tests and packaging. Looking forward, is there any aspect of the industry where they're more likely to succeed than not? I take your conclusion that you think that they may not, but are there any, if you break that down, is there anything? And then secondly, on the investment fund, one of the objectives of the funds is not just for investment in manufacturing for fabs, but also in mergers and acquisitions. And I'm wondering if you could specifically address mergers and acquisitions by Chinese firms of other multinational firms with that money. What do you think will happen there?
Okay, so the first question, I basically agree that China's been successful on assembly and testing, but they're not necessarily Chinese firms that are doing that. And it's been, even within China, I think that was never a priority because even they sort of regarded it as the maybe incorrectly, but the non-technology intensive part of the IC industry. But there's an awful lot of that activity going on in China, so it's hard to say it was not successful. To the extent that it was industrial policy, I think it's more the general subsidization of industry, that cheap land, low to zero taxation, effectively, forget about the top line policies, but when you deal with local governments, certainly spurred industrial investment in China. I think where they ran into more trouble with the more technologically sophisticated activities is the those activities were more difficult. It wasn't just you get people to invest, as what Rob alluded to earlier. Some areas you need more than just the investment, and the vehicles they ran them through, primarily state-owned firms. For the second question about the mergers, I mean, it's interesting that they started happening last year, sort of in anticipation that there would be a lot of promotion, both from the central government and from individual local governments. And there's even, Spreadtrum and RDA, which are in this, mobile space that China probably incorrectly has, they tend to fixate on certain, whatever is the topic of the day. Oh, now it's Internet of Things, so now they focus on that. But, so the idea was that they would combine these two firms through what turned out to be through this Tsinghua group, Ziguang, I guess it's called Unigroup now in English. It used to be called Unisplendor. I think that's a better translation, personally. But that group has no background in IC design or anything really IC related. It's sort of a strange vehicle, through even stranger than some of the past ones, through which to do this. And there was, particularly with RDA, there was sort of a fight between Tsinghua and then, perhaps as a proxy of the central government, and the Shanghai government's own investment vehicles had also wanted to buy that out. So they in turn then bought out this, I think, very promising firm, Montage. But unfortunately, I think that firm, they saw a good deal. They were going to give them pay a substantial premium over their stock market price on NASDAQ. So why not exit in this manner? But I don't know. The person who founded Montage also has a history of, after he sells his company to someone else, like rapidly the company kind of collapses. I predict once Howard Young leaves Montage, and I don't know the details of his contractual obligations post-merger, it will slowly not go so well. And now with OmniVision, there's talk of another Shanghai investment vehicle wanting to do the same thing with OmniVision. Now, the argument you hear from official sources in China is, we have these state investment funds. They're either going to invest in local firms or do these mergers and acquisitions, but they're going to be privately managed. But I think this will be very difficult within China's political system to actually carry out these things. It's what, who cares if it's Yu Zhongsheng or whoever at the top is only sort of protecting them. They've sort of said similar things in the past about, Ming Chia and various things, and they haven't fulfilled those promises then. So I don't think there will be a very credible commitment to letting private managers actually manage these things.
Other questions? Yeah. Bill Moore in Applied Materials. Looking at kind of the cultural factors that have made Silicon Valley so successful in this industry here in the U.S., kind of the creative destruction, the job churn, failure is a rite of passage, and so on. Looking through that cultural filter, how does that impact your handicapping of China and India in this industry?
Yeah, that's a good question. When you talk to people working for multinationals in India, they would argue that they are much more in tune with at least the U.S. semiconductor industry culture than the people in China. But I think in both places, there's, at least within this industry, there seems to be enough entrepreneurship of people willing to take risks. To be fair, though, you would have to say that the model they've adopted in India is inherently less risky. It's low investment. We're just going to I tend to hesitate to think that culture is an ultimate sort of obstacle. Just thinking, I mean, Korea culture is not perhaps like Silicon Valley culture, but they've just organized the industry in a different way. So, and if we look at Japan, maybe their semiconductor industry is in decline, but I don't know if that's purely sort of cultural reason. So I probably would be hesitant to use that as the main handicapping device.
Yeah, in the back.
James, sorry, two questions. One, you've talked mainly about design, chip design. Did you say something about, since China, for example, does a lot of production, design of tools for testing and tools for production? In fact, since we have talking about applied materials, there's some element of that. And the second one is, we know that in the 90s and in the early phases in both China and India, returning expatriates played a very large role. Are they still playing a large role, or is it more indigenous?
So the first question's about the capital equipment side, or
Well, design tools for testing and tools for manufacturing.
Right. I mean, China's clearly wanted to support. Just like Korea and just like Taiwan, have after getting a substantial amount of investment in and on the manufacturing side, wanted to support their own local manufacturing firms. Thus far, I don't see them being much of a factor, but this isn't an area that I've looked very much at, but the little I have, I don't hear them held out as, I mean, there's concerns that the state will support them, but that's different than them being actually, serious competitors to place it as like applied materials. On the expatriate side, I think there's still quite significant. There's a real bifurcation, I would say, on the design side, a real bifurcation. There's the very, very local firms. And what they do, a lot of those are kind of firms that are trying to, sell into these very localized channels at low margins. They just look very different than the firms that are founded by the returnees. So Howard Young's Montage is an excellent example. Much more, they were a very niche firm, but they were doing a relatively sophisticated product, and one that, in their case, actually wasn't fully predicated on the Chinese marketplace either, or even mainly predicated on the Chinese marketplace. So that I would say the expatriates still play a role, and there's still these policies to lure back expatriates. Though I think that there's been a de-emphasis by, particularly I think I see this through local governments, less sort of interest in that than 5-10 years ago, when you saw the proliferation of all these sort of, returnee parks, science parks, and the like.
If I could just jump in on I don't think we have good data on the manufacturing tools and whatnot, but so China now currently accounts for about 1 to 2% of the global market in terms of production, and I think they only account for about 5% of their own domestic consumption, whether that's for internal uses or for export. So they're not a big location for manufacturing equipment right now, but as part of their plan, they want to lead in all aspects of the supply chain. So that includes the equipment side, and so that's very much part of the mix here.
Yeah, here.
Dick Benado from Institute for Defense Analysis. A couple of questions on point. One on the equipment side in China. I think you should talk to Applied Materials and what happened when some of their capabilities there were essentially relocated into a Chinese firm that helps them move into the supply chain. Is it's a pretty big issue in terms of the transfer of knowledge and capabilities. Second of all, on the issue of will such policies work and how can they work, and what the alternative policies are, and why certain countries like China and India would do this, I think the answer is Korea. Look at what happened in terms of Samsung and LG and how they've moved into prominent roles in integrated circuits, raising the question, why can't we do it? What can we do? And another question is looking at the alternative models, how they did that. The third point, which I think needs to be looked at, is what kind of industry we're talking about today. I wrote an article in Issues of Science Technology a couple of years ago about why don't we care anymore in the United States about microelectronics. Well, one of the reasons is it's commoditized and is not the dynamic industry that it was when Moore's Law was Moore's Law, which it isn't anymore. Raising the question, what will it be? And who cares what it will be relative to what will be next in terms of innovation and development. And I think that's one of the big issues, and that is what we're seeing here is a commodity-like behavior where companies or countries are looking to become the next steel maker, if you will, with integrated circuits. It may not be that big a deal, except from the standpoint, as Rob was saying, of overcapacity, making it very cheap products available for everybody. But the question of how viable an industry will be the second question.
Anybody want to take that one, or any of those points?
On the second question, I mean, I think the steel industry is a good counterexample. I mean, there's the steel industry and there's the steel industry. There's certainly a lot of steel makers in high-wage economies that are profitable and contribute to those countries. Only the U.S. The U.S. is basically the only major economy where we have, less steel capacity than consumption. But I think there's a little bit danger for the U.S. to continually just insist on the short-term returns perspective, because you end up in situations like that where you have a structural trade deficit. The industry is maturing, but I think there's still large segments of it where a lot of money can still be made. If you look at the rising competitors, I mean, they're paying healthy wages in certain areas like IC design for the workforce in these areas. And I mean, there's the linkages. If China wants to, and I think David's right, their ambition is to just take everything. Well, that probably would not. I mean, what was beneficial to firms like Applied Materials probably was that Taiwan and Korea, particularly Taiwan, one, favored their tools over the Japanese ones, and two, were never successful in developing their own industry. But if that doesn't repeat itself as the pattern, then the U.S.'s last really strong capital equipment sector may go down the tubes, which probably would not be a good thing.
Well, I think also as well on the point towards, is the industry becoming commoditized? Obviously, every part of or structure of an industry has some component that becomes commoditized. But I think by and large, particularly with the United States, there still is a significant amount of innovation, significant amount of R&D in areas, like cognitive computing or providing new R&D of technology around IC for new innovations in M2M communications, connected automobiles, big data applications, some of the finite niche requirements of a lot of the new internet companies or healthcare applications. And so I think you do see still a lot of innovation, particularly here, because we have a lot of the cutting edge applications and demand for a lot of the semiconductor technologies. And the question is, is China going to? They're probably going to, continually to be playing the game of catch up of, oh well, the U.S. is doing this, so let's do this, and then you'll see that sort of structure of big government investment over capacity, and they may not be successful, but at the minimum, it'll be disruptive, where it's going to hurt, like the Korea example, firms that are trying to compete in that market at their bottom line. So
So, I agree with Jimmy's comments about the opportunity for continued innovation, and there is the risk of commoditization and the point about Rob's point about overcapacity, and just getting back, Rob, to your point about, I wasn't trying to say that this was inevitably a good thing or even mainly a good thing. It has the potential to be a good thing for the industry, and let's just pretend they adopt the innovation agenda that you've written about for so many years. That would be a good thing. And
Not holding your breath, Rob.
right, no.
And then we could adopt it too.
Right, well, and that might push the United States to get in the game and make the investments that our government should be doing to grow this industry. But it's not just political spin, but our message shouldn't be, and I don't think it can be, our goal is to suppress your industry or to prevent you from developing this important industry, but rather it should be do it in a way that's open, transparent, non-discriminatory, that is integrated with the global ecosystem, and let's raise everyone's game. And we have to trust but verify.
So I think, Dick, one of the points you make, I think, is really important here, and that's, or maybe they all are, but I'll point to one, which is we have to have a two-pronged strategy, and one of the prongs is what David is doing, and that's and Jimmy, to make sure these countries, India and China in particular, reduce their distortionary policies as much as possible and move to these good policies, because they would do less harm. But the second is we need to avoid commoditization, and we did a great event earlier this year or late last year off in the Senate on is Moore's Law dead? Not dead, but it's old. And the key, I think, for us is to go beyond Moore's, the next steps, and that's going to be hard to do if we don't have better policy. So we have the 27th worst research and development tax credit in the world now. We don't let companies write off. Pardon?
It's zero.
I thought they did renew it. In any case, who knows? Under the Camp bill, it would go down to probably 50th. The Camp proposal. So we could have a much better R&D. We don't let companies write off these massive capital investments. We make them write them off over a long period of time. And then lastly, we have some policies that are proactive, like the Albany Nano Center, and then what used to be called Focus Center, but now it's called something else. In any case, this great program that funds about 6 cutting-edge universities in partnership with industry that DARPA funds. But these are small programs, and we need to, if we're serious about keeping ahead of these countries, we need to be putting in place 5 times more of the resources into these programs, and at the same time, advanced STEM programs for semiconductor engineers. So, if we were serious about this, we'd be fighting the 2 battles. We're not really fighting either battle very well.
Maybe we should just leave it there and thank everybody for coming, and thank the speakers, and thank Doug for